Good morning, folks. This is tutorial number 6 or video number 6 from a playlist which is called Motion Design in 3D Experience, but the one that deals with the kinematics model. There's two of them, Motion Design 3D Experience Dynamic playlist and the kinematic playlist. This is the kinematic playlist. Now, I have done something very similar to this in tutorial 5 or video 5. The difference is that there, instead of using from a sketch, I'm using from data input, data points. Okay, so it is an alternative way of doing that problem uh, as far as importing the data for the physics of the problem. Okay? So here's the situation: we have a block that is traveling down a track. So that is a prismatic joint that I'm going to be creating. And I have a propeller on the top or an arm on the top which is rotating about the block. Okay, so that's going to be revolute in my case. So I have some dimensions here. Now these dimensions are irrelevant, but for the sake of concreteness, I'm putting something that I'll build my model based on these sizes. Okay, now when it comes to specifying the physics of the problem, there are many different ways of doing it. And it turns out that you can actually select from a menu. This is a pull down menu. Video 5 dealt with this data points. That is not what I have here. This video 6, is from a sketch. Okay. So when I say from a sketch, it means that you select this item from the pull down menu. Uh, the physics of the problem goes like this. The location of the block as a function of time is given by this graph, okay? So inch per second as a function of time, this is what happens. And the angular position of the arm or the propeller as a function of time is given by the graph below it. Now, it is possible to use these as sketches, but the alternative is to uh, kind of scale these or non-dimensionalize these so that horizontal axis goes between 0 and 1 and the vertical axis also goes between 0 and 1. And this is exactly what I'm going to do. So I'm going to create this kind of a sketch in my model and this kind of a sketch for a model for the propeller and say this is the information, but a horizontal direction of 1 unit, whatever it is, inches for example, corresponds to actually 10 seconds. And a vertical unit of, for example, 1 inch will correspond to 8 inches. So these are going to be specified later on. Now, what I'm going to do, these sketches somehow I have to make it. And there are many ways of doing it. For example, I can take this sketch which goes with the block and put it in the block as a sketch sitting there, which can be used later on. And this is the sketch that belongs to propeller's position. And I can put that thing, for example, in the propeller. But I'm going to do it differently in the sense that after I create my model, which is made of a track, a block, and an arm, on the very top of a model assembly, I will create a 3D shape, and in it, I put distractions of this type so that it's not all uh, bungled up with other things. So these two sketches, I'm going to put it in a shape, 3D shape, which is primarily created for storing these two graphs. Okay, so this one goes like that. And this one goes like this. We'll be creating it. Remember, these are the non-dimensional ones. And I already showed you that when it comes to pointing to the physics of the problem, which is these two graphs, you use the pull-down menu for function and select from sketch. And there are other ways of doing the problem, of course, many other ways. Okay, so let's go ahead and do this. Okay, so I'm in assembly. So let me insert my first part. I'm going to call it track. Okay, so let me rename this thing to be track and track. All right, let's go make it. It's just basically a long box. Okay. So on that vertical plane, I will sketch. I'll sketch something that looks like that. Let me dimension these things to stick to those sizes that I have here. So I'll make this thing 1 inch, and this height, what is this height? And this height will be 0.25. All right, exit. There we are. I'm going to pad it by 11 inches. Good. So this is going to be the track. Now I'm going to insert the block. So all the way on the top, insert 3D part. I'm going to call this thing block. Properties. And block. I'm going to change the color of it so that it becomes green, just for cosmetic purposes. So let's go make it. Double click on the 3D part, 3D shape, on that vertical plane, sketch, basically a square 1 by 1. Mention these things. This is also 1. Exit, and pad it by 1 inch. There. Okay, now on the top of it, I'll make a little indentation so that I can use it as the axis of the propeller. That's really not necessary, but why not? So I'll make a little circle here. I mean, doesn't matter exactly where it is. Exit, and make a, actually, let me make a pocket instead. That's fine. So there we go. Now we're going to do the propeller all the way on the top. Right click, insert 3D part. I'm going to call it arm. Yeah. Double click to go into part design. And on that plane, I will sketch something that is similar to that propeller. The size of it doesn't matter, although in the PowerPoint I'm saying 3 inches. That's really totally irrelevant. There. Okay, if I want to make it a little bit nicer, I want to make this thing control that thing tangent to each other. We can do that. Tangent. Okay, very good. And this control that, although again it's unnecessary, but that's okay. I'll make it concentric. Okay, good. Exit. And then we're going to pad this thing in the other direction, and I'll make it 0.2. Or the color of it I'm going to change also. Right click properties, graphics, we'll change that to orange. Okay, let's do a quick save. All right. It's saving it. Remember, these are all on the cloud, depends on communication between the server and your establishment. Now, remember I told you that I'm going to create a 3D part on the very top so that it's easier to find it, and then put my sketches in it. So let me go on all the way on the top and then insert and a 3D shape. The shape here, notice that the 3D shape has been put in the top, and sole purpose is actually create two sketches and put it in there. Now I can do that anywhere I want. I can do it in XY plane, XZ plane, YZ plane, but I'd rather do it a different way. So let me do the following. So I'm in the part design. Which part? 3D shape. Okay, that's the storage, yeah, storage area for those graphs. I'm going to create 2 points. A point with the coordinates in that part. A point with the coordinate height of maybe make it 4. So it's right there. Another point. You see why I'm doing this thing, and say height that maybe to the right by maybe 5 inches. There we are. And I'm going to create 2 planes passing through these 2 points with parallel to this face, the back face. Okay, so make a plane uh, uh, parallel through a point. The first one is going to be this, and it's parallel to that, or not parallel through a point. Yeah, this. So there's my first plane, and same thing again for the other fellow. So this is the point, and this is the face. There. So I've created 2 planes in this 3D shape here that I've created. And now I'm going to make 2 sketches. So here's the first one. I want to make it look good so that it looks like what I showed you, namely the coordinate system being at this corner point, etc. So here's the way it's going to go. And this is not, unless you're a very experienced CATIA user, this is not very straightforward. So position sketch, look, position sketch, okay? And what I want to do, I'm going to click. Well, I'm going to select the plane right there, select the plane. And then for the origin, I'm going to project this point. Notice that it put the coordinate system here, and I can go ahead and create my sketch. All right. Okay, so let's do that. My sketch goes, where's that profile right there? So the first one is for the position. Goes like this, like that, like so. I'm gonna put, oops, close that there. Okay, and then dimension it. So the height, it's not this one. So this height, dimension from here to here is 1. Look at the graph. It looks like this, right? 1, 0.4, 0.6, etc. So then I'm going to do this one, horizontal. That's going to be 0.4. Okay. And then again, dimension here, this is going to be 0.2. And finally, that guy, horizontal, also 0.4. So what you see there is actually this sketch. Then exit. There we are. So there's the sketch. This first one is going to be for position of the block. Okay, I can rename it so it says position, but I'll leave it like this. Now do another one, another sketch for the element. Select this plane. For the origin, select projection of that point. Good. Now we create the other graph, and the other graph looked. Let me see now. It looked like this. Yeah. So profile from here to here. And put some dimensions. Once again, this is horizontally, it's going to be 0.4. Okay, this one is going to be 0.2. And this last one, also 0.4. The height here from here to here is going to be 1. And finally, from here, oops, from this point to that is going to be 0.5. 0.5. Okay, so the graph that you see there, this graph is that graph. Okay, good. We're in business. So let's do a quick save. You go all the way to the assembly. Okay, all the way to assembly, and let's apply our constraints. So as a engineering connection, I'm going to fix the track. Track is fixed. You can see that. And then we do a prismatic joint between the block and that track, and there's a template that's going to show up. It really doesn't matter. Just for the sake of concreteness, I use this one. So this edge and that edge, this plane and that plane, and I don't need this last set of last two boxes, so I just delete it. Don't need it. Oh, okay. Now let's do our revolute. I usually use this one. It makes no difference. You need a revolute joint, so axis to axis, plane to plane. So I'm going to choose this axis and that axis, this plane and this plane. And I don't need this last two boxes, so I just delete them and say OK. So basically, we have created our joints. Track is fixed, prismatic, and revolute. Now, we're going to go to motion design. Please keep in mind that I've done problems like this using different packages. I've done it with CATIA V5. I've done it with the mechanical systems experience and mechanical system design, which is the granddaddy of this motion design, application. But anyway, so I will go to motion design. As soon as you go there, mechanism is going to be created, and we're going to keep it because we don't have an old one. This is the one, and a scenario is going to be created, etc. So this is the more glorified version of essentially mechanical system design and mechanical system experience put together in an application. Now, notice that it says, do you have one or do you want to create one? Well, I want to create one, so we say OK. And as soon as you do that, of course, the mechanism is created here. You can see that with joints and everything. And down here, a scenario has been created, and it's a step, and it's going to be dynamic. Now, I don't want dynamic, first of all. Let me double click on this thing. I want kinematic. And I want to go over 10 seconds. Fine. And when it comes to options, I want position, velocity, and acceleration. So this is the first thing that I did. All right, good. Now, in motion design, you have to introduce these drivers. Essentially, drivers are the equivalent of commands in the CATIA V5, the good old CATIA V5, and its reincarnation in the 3D experience, which is which is there. It's called laws and things like that. Okay. Anyway, so let's go to the mechanism and find the driver. There's the driver. The first one is going to be driver one is going to be for sketch one. Okay, for that sketch. And if you want, I can call it. Just for bookkeeping purposes, I'll call it prismatic. And the joint is going to be that prismatic joint. And I'm going to use a function. Click on this icon. See that? Click on this icon. Okay, this thing here, first of all, it's a prismatic joint, so we want the vertical axis to be length. And I want to pull down menu from sketch, length, and 1 inch horizontally in that sketch, by the way, let me go select my sketch. You can do it from the tree or you can do it from the graph here, right here. I selected it. Notice that immediately it picked up. But 1 inch of it is 10 seconds, and 1 inch vertically is 8 inches. Okay? Now, I may have to come back under this scale and offset set of tabs, a set of choices. I may have to come back and change this 1 to -1 if it goes in the wrong direction. Well, just leave it the way it is right now. Say, okay, good, and then close. Now we do another driver. Let me call this in Revolut, just so that I know which one it is. And from the join, you select the Revolut join. Go to f of x, go to function, not f of x, go to function. Change this thing from sketch. Now, Revolut, the vertical axis is actually angled, just leave it the way it is. And the sketch, I can select it from the screen or from the tree. This is the one for angle. And 1 inch horizontally is 10 seconds, you know that. And 1 inch vertically is 720 degrees. Notice that here again there is a scale tab here. So the direction of rotation of propeller, if it's wrong, you just make a -1 here later on. But I don't care about that. You say okay, and that's okay. So notice that when I did these things, these two functions were created. Where is this? These two drivers were created. All right. And that's pretty much it. So let's go check it first of all. If I click on this, it shows me the preview, right? See that? Motion Manager says preview. Let's see. If it goes in the wrong direction, we go and flip the side. Give it time. Yep, it's going in the wrong direction. And I, in the older versions, in CATIA V5 and its reincarnation in 3D Experience, it is possible to flip the direction of the arrow a different way, but I can figure it out here, so I just have to go and change that to minus. So exit this first of all. Let me go to that driver. We can either go to the driver or you can go to the sketch. It really doesn't matter. I'll go to the sketch, it doesn't matter. And notice that here I put a minus sign, and this is for the prismatic joint. You say okay. Now, if you say preview, it should go in the proper direction. I wish there was a better way of having documented that. But anyway, that's it. Now this is just a preview. It's not a run. So exit this thing. Now we're going to run it. So we go to simulation, and we're going to go to run analysis case. Remember, these things are automatically created when I went into the motion design. So let's go run it. Wait until it says 100% complete. And now we can go, for example, if you want to create a animation, let me go and select the result, the last tab, and then go to results. Here's the animation. Okay, so you can see that. Good. Okay, 5 seconds, 10 seconds, very good. So close that. If you want to make sure that this ends up in your uh, assembly, what you can do is you can go back there, select this, and then say export animation. Now, if you go to your assembly, you see that the animation has also been added. So even though you may not have the license to motion design, but you can put it in the assembly design, put the animation in the assembly design, and people can actually, if they have your assembly design folder or file, they can actually see it. But it really doesn't matter. Let's go back here. Now let's go to 2D plots. What do we want? So let's actually check the prismatic joint. So use the pull down menu, prismatic, and show me the position. Add to the plot. Notice that this is exactly that, except that it's flipped because I made the scale -1. Okay. And let me get rid of that. Let's go to the revolute rotation. And this is exactly that plot, but of course the actual original plot, which was dimensional. Now you can also put probes here and plot the velocity, acceleration. For example, let me do the following. Suppose we go here and we use a probe, which is called kinematic measurement. Okay, so yeah, we select this point. That's where the probe is created. We say okay. We have to run it because this was not created. Add the probe later on. Good. This is done. So now we go to results, 2D plot, and here I can select the kinematic measurement. And let's say I look at the X and Y position of that tip. Obviously, they're going to be something like that, sinusoidal, and then the places where it was sitting put actually stays at a constant value. And that's it. Good luck.